Hi all, good morning. Welcome back to my channel. Let's start Maths, grade 11, chapter 6. Chapter name is Permutations and Combinations. The subtopic is Fundamental Principle of Counting. Learning objectives. After this session, learners will be able to define the fundamental principle of counting, apply the fundamental principle of counting to solve problems. Introduction. You have a suitcase with a number lock. It has 4 wheels, each labeled 0 to 9. The lock opens only with a 4-digit sequence. No digit is repeated.
How do you solve this question?
Let's do. You remembered the first digit is 7 and you have forgotten the remaining 3 digits. So, how many 3-digit sequences can be formed from the 9 remaining digits? See, here, assume this the lock is in display. So, first digit you clearly remember the digit is 7. So, this here. Next, it can be used 9 choices, excluding 7 from 0 to 9. So therefore, this can be filled in this 9 ways. And this third one you can use is 8 ways, because already in the second one you might have used 1 digit apart from the 7. So 2 digits over amongst 10 digits. So you have left out 8 choices. The last option you can use only 7 choices, because among the 10 digits 0 to 9, 3 already you have used. So there will be 7 choices are left out. Thus, total number of sequences possible is 9 into 8 into 7, that is 504.
Oh, now I get it.
Let's start fundamental principle of counting. Mohan has 3 pants and 2 shirts. How many different pant shirt pairs can he wear? Pants there are 3 ways, then shirts 2 ways. Then if we combine here for pant 1, we can use shirt 1 and shirt 2. So P1 S1 is a one possibility. Next P1 S2 is a possibility. Similarly, for the pant 2, you can use shirt 1 or shirt 2. So P2 S1, P2 S2. Then finally for the third pant, we can use shirt 1 or shirt 2. So P3 S1, P3 S2. So there are total 6 possibilities are there. 1, 2, 3, 4, 5, 6. Therefore, total number of ways different pant shirt you can wear is 3 into 2. That is 6 pairs. If an event can occur in m different ways, following which another event can occur in n different ways, then the total number of occurrences of the event in the given order is m into n.
How many 3-digit numbers can be formed from the digits 1, 2, 3, 4, and 5, assuming that 1. Repetition of the digits is allowed, 2. Repetition of the digit is not allowed.
Let us solve. See here, that we need to have the 3-digit sequence, okay? But here the digits repetition is allowed. So first digit, how many ways you can use? 5 ways. Second digit also 5. Third also 5 options there. Therefore, if this repetition is allowed, we can use 5 into 5 into 5. So number of 3 digits formed if repetition of the digits is allowed is 5 into 5 into 5. That is 125. Second one, if repetition of the digits is not allowed, then the first option we can have 5 options. Then second we can have 4 options. Third we can have only 3 options. Then number of 3 digits formed if repetition of digits is not allowed, then 5 into 4 into 3, that is 60 ways the 3 digits form.
Oh, that is nice. How many 3-digit even numbers can be formed from the digits 1, 2, 3, 4, 5, 6? The digits can be repeated.
Here, whenever the examiner asking is 3-digit even number, we should ensure that units the digit should be always even number. Among the given digits 1 to 6, there are 3 even numbers and 3 odd numbers. So in the units place, we have to use only even numbers, that is 2, 4 or 6. So the possible digits for the units place is 2, 4 and 6. Only 3 options is available. But in this tens place, we can use all the 6 digits. So we can use 1 to 6. In the hundreds place, you can use all the 6 digits 1 to 6. Therefore, the number of 3-digit even number possible in this using the digits 1, 2, 3, 4, 5, 6 is 6 into 6 into 3. That is 108. How many 4-letter code can be formed using the first 10 letters of the English alphabet if no letter can be repeated?
Oh, this seems interesting.
Yes, here we should ensure that one first of 10 letters of the English alphabet is not all the 26 letters. Okay, so we should use only first 10 letters, but we need to use this 4-letter code. Okay, so it will be having the first letter, second letter, third letter, fourth letter in the 4-letter code. First letter you can use here 10 choices. As repetition is not allowed, then the second letter you can use 9 choices. The third letter it will be having the 8 choices, and the fourth letter will be having 7 choices.
Oh, I know this one. So you have to multiply 10 times 9 times 8 times 7.
Exactly. So total number of ways 4-letter code possible using first 10 letters is equals to 10 into 9 into 8 into 7. That is 5040 will get. Therefore, in 5040 ways a 4-letter can be formed using first 10 digits.
How many 5-digit telephone numbers can be constructed using the digits 0 to 9 if each number starts with 6, 7 and no digit appears more than once?
Here in this question it's clearly given number start with a 67. That means here the first digit here is 6 and the next digit here 7. So remaining you can use this one excluding these 6 and 7 here. So from this 0 to 9 there are 10 digits are there. Already you have used 6 and 7. So from the 10 digits remaining 8 options you can use for the third one. The 7 options you can use for this second digit. This one you can use for the sixth option. Therefore, you will be having this first digit will be having only one option, that is 6. For the second digit will be having only one option, that is 7. For the third digit we have 8 options, that is excluding 6 and 7 from 0 to 9. So for the fourth digit we will be having 7 options excluding this all the 3 options. Then for the fifth we will be having 6 options excluding all these 4 options.
Therefore, the number of 5-digit telephone numbers formed using the digits 0 to 9 with the first digit as 6 and the second digit as 7 without repeating digits can be 1 times 1 times 8 times 7 times 6.
Exactly, that is 336.
Wow!
A coin is tossed 3 times and the outcomes are recorded. How many possible outcomes are there? When a coin is tossed, you will get head or tail, right?
Yeah.
So, if a coin is tossed 3 times, the possible outcomes for the each toss is head or tail. Okay, first time you will be tossing the coin, you will get head or tail. So, number of outcomes will be 2, right? Second time also, you will be getting head or tail. So, number of outcomes will be 2. Third time, head or tail. So, 2. So, this total number of possible outcomes after tossing the coin 3 times
will
is
be 2 times 2 times 2, which is 8.
exactly. Let's start question number 6. Given 5 flags of different colors, how many different signals can be generated if each signal requests the use of 2 flags, one below the other? Given that signal requires the use of 2 flags among 5 flags. Let us assume these are the 5 flags colors. Okay. Here we need to use 2 colors one below the other. Okay. This first color you can use as a 5 ways. The second color you can use 4 ways, because assume that first you have used the green, the remaining you will be having options of the 4. If you assume the first one is remaining, you can use the 4. So first color is 5 ways and the second color is 4 ways. So different number of signals possible using 2 flags with the 5 different colors are
5 times 4, which is 20.
exactly. Thank you.
Come again to our channel.